Aim, how do we determine the characteristics of organic compounds? So the do now says here, what does the term organic mean? Well, what is organic? Press pause, and then we'll continue after you come back. Okay, we're back. So, organic typically means something that was living or once lived. That could be an animal, insect, plant, any type of matter that has existed once before. So, when you think of the word organic, what element comes to mind? That's right, carbon. So, organic means something that was living or once lived. So, think of carbon, which is basically the life form, okay, of everything that was living or once lived, as a carbon-based life form in this planet. Okay, let's move on. So let's skip down to over here. This is a very short lesson because it's basically the characteristics of organic compounds. All right. So organic compounds, all right, are non-electrolytes. Well, going back to what we learned before, we learned an electrolyte, right? See the word electric, right? Here's an electrolyte. Has the word electric, basically over here. Means that it's a good conductor of electricity. And what makes a good conductor of electricity are the subatomic particles, electrons. Now, non-electrolyte means not a good conductor. So it's a poor conductor of electricity. So examples of poor conductors of electricity are plants, like trees, bushes, flowers, animals, like us, and sugar. Why? Because what element do they all contain? Well, they all contain the organic element carbon. All right. Another example of organic compounds are if you ever take vegetables and put them in water, are they going to dissolve right away? Well, no, they do not dissolve, neither do we. If you put us in water, we will not dissolve readily. Yes, if you're in the pool for a long period of time, your skin starts to get a little shrivelly. Okay, that's the beginning of the process of basically being soluble or dissolving. But in general, plants and animals are insoluble. Hence, that means they do not readily dissolve in water. Does not dissolve in water. Okay? Now, think of cooking, let's say, fish, chicken, beef. Okay? Do organic compounds have high or low melting points? Well, let's think a second. If you ever burn yourself touching a hot plate or anything, you'll notice that the burn will, if you touch the hot plate, boom, your hand will burn right away. In fact, if you left your hand on the hot plate for several seconds, you can actually melt your skin there. So, in general, organic compounds, such as animals and plants, have low melting points as compared to salts and metals. Right? So, low melting points, in other words, they melt at a low temperature, at low temperatures. Substance example, boiling. So if you notice down here, I have a pot that's boiling here. Some meat, all right? By the way, this was from the funny clip of Indiana Jones, okay? All right, so apologize. I don't know what just happened here. Okay, let's go back to over here. All right. Okay, so low melting point, all right? We said low melting point. Okay, poor conductor, insoluble in water, which means it's not conduct readily. Low boiling point. So if you can actually cook a chicken, right, and boil it, and it'll cook very nicely because in fact these substances have low boiling points or boils at low temperatures. Just think about it. You can boil water at 100 degrees Celsius, and then you can boil a chicken at the same temperature. While if you want to boil a metal, it'll take thousands of degrees Celsius. Okay, let's move on. Next thing over here. Characteristics of organic compounds. Well, carbon can only hold, well, look at this molecule over here. 1, 2, 3, 4. Carbon can only hold 4 bonds. That's the maximum it can hold, all right? If all organic compounds are made up of, well, what do we just say? Well, if you look at all these bonds over here, these rings, okay, they're attached to each other. All are made up of carbon. Okay, carbon. Yes, there's other elements hanging off. There's hydrogen chain, all right, it's called hydrocarbon chain. Oxygen, some of the diatomic elements, so on and so forth. Moving on. Characteristics. Now, don't do what this guy did here. He's Mr. Funny over here. Uh, carbon forms. What type of bonds here? Well, if you're sharing electrons, going back to bonding, if you share electrons, that is the covalent bonds. Remember, transfer electrons ionic, and when electrons are moving, that's metallic. Now, if you notice, example of covalent bonds is methane. Methane is something that comes out of natural gas you find in your stove, or when you fart, like this funny guy over here decides to rip a fart. Moving on. Over here. Organic compounds form what type of molecules here? Well, they form, well, from the word snap, symmetrical is nonpolar, asymmetrical is polar molecules. Again, we drew methane before, right, guys? So it folds both ways. It folds both ways. You are symmetrical nonpolar. Okay? All organic reactions are, well, faster or slower than ionic reactions, which are salts. They're slower. Again, if you throw a chicken in water, it's not going to dissolve. It reacts slowly. If you throw salt in water, it dissolves quickly. Okay? And what type of shape do they all have here? Well, if you're going back to bonding, you look at a methane molecule, this has what's called a tetrahedral shape. And the last thing I want to go over is that carbon atoms form rings, chains, and network structures. Okay, you find that some carbon atoms can form a molecule 30, 40 carbon lengths long. It's amazing. Carbon can bond to almost any element out there. That's why it's basically the element of life.